Section 5. Hunger and Eating. Introduction. All of us, including psychologists, have difficulty understanding why people do the things they do. If behavioral control was simply a matter of immediate, external, observable reinforcement, we should not be so baffled, not intrigued by humans. There are several reasons why behavior and feelings are so mysterious. Even the explanation of simple behavior is difficult. Why some people can stop eating and others are obese yet cannot control the appetite. Objectives. At the end of the lecture, the students are expected to be able to explain why simple behavior are carried out and why some behavior cannot be stopped by mere will and desires. Also, to understand that there are bases for some of our behavior beyond instinct. Content. Simplistically, we can say that we eat because we are hungry and we stop eating because we are satisfied. Ultimately, eating supplies an organism with the matter and energy necessary to continue living. Non-humans will typically eat a balanced diet with the appropriate number of calories if allowed to, not my cat, though they are warped by their proximity to humans. Some research indicates that young children will do the same. Stomach signals are not the only factors that affect hunger. However, people whose stomachs have been surgically removed still get hunger pangs, and the stomach may contract to signal hunger, but the stomach also can send signals that stop hunger. We all know that a full stomach can decrease our appetite. In fact, the stomach actually tells the brain not only how full it is, but also how much nutrient is present. That is why rich food stops your hunger faster than the same amount of water. The hormone cholecystokinin (CCK) helps start the digestion of food, travels to the brain through the bloodstream, and signals you to stop eating. Naslund, Hellstrom, and Kral, 2001. As explained in the following sections, there is a lot more involved in hunger than an empty stomach. The lateral hypothalamus, LH, involves the hunger center. The LH tells the organism when to begin eating and drinking. Damage to the LH can cause aphagia, a refusal to eat or drink voluntarily, to the point the organism must be force-fed through tubes. The lateral hypothalamus also plays a role in rage and fighting. The ventromedial hypothalamus, VMH, involves the satiety center. The VMH tells the individual when he or she has eaten enough. Brain lesions in the VMH typically lead to overeating and obesity. This is called hyperphagia. The glucostatic hypothesis asserts that hunger is tied to glucose levels in the body. Glucose levels do appear to influence the immediate perception of hunger and feelings of satiation. The lipostatic hypothesis asserts that hunger is tied to fat levels in the body. Fat levels do appear to be involved with general eating patterns. There is general agreement that both glucose and fat levels influence hunger. Set point theory. The theory that the hypothalamus wants to maintain a certain body weight will trigger eating and lower metabolic rate when we drop below that weight, will trigger cessation of eating and elevate metabolic rate when we hit the set point. Blood chemistry. 3 important chemical substances are involved in hunger, eating, and satiety. The sense of being filled and not wanting to eat more. Glucose, insulin, and leptin. Glucose blood sugar is an important factor in hunger, probably because the brain is critically dependent on sugar for energy. One set of sugar receptors located in the brain itself triggers hunger when sugar levels fall too low. Another set of sugar receptors is the liver, which stores excess sugar and releases it into the blood when needed. The sugar receptors in the liver signal the brain when its sugar supply falls, and this signal also can make you hungry. The up mouse has a low metabolism, overeats and gets extremely fat. A particular gene called OB normally produces leptin. However, because of a genetic mutation, the fat cells of OB mice cannot produce leptin. Leptin strongly affects metabolism and eating, acting as an anti-obesity hormone. Brain processes. The hypothalamus has very important roles in regulating important body functions, including hunger. More specifically, activity in two areas of the hypothalamus contributes to our understanding of hunger. The lateral hypothalamus is involved in stimulating eating. When it is electrically stimulated in a well-fed animal, the animal begins to eat. And if this area of the hypothalamus is destroyed, even a starving animal will show no interest in food. The ventromedial hypothalamus is involved in reducing hunger and restricting eating. When this area of an animal's brain is stimulated, the animal stops eating. When the area is destroyed, the animal eats profusely and quickly becomes obese. Today, neuroscientists believe that although the lateral and ventromedial hypothalamus plays roles in hunger, there is much more to the brain's role in determining hunger than these on-off centers in the hypothalamus. They are exploring how neurotransmitters, the chemical messengers that convey information from neuron to neuron, and neural circuit, clusters of neurons that often involve different parts of the brain, function in hunger. Summary: primary drives, biological needs that trigger a corresponding state of psychological arousal or tension, e.g., hunger, thirst, sexual arousal. One factor in hunger regulation is blood sugar, glucose levels. Low blood sugar levels signal hunger, and high blood sugar levels signal that the organism is full. This is the end of section 5. Thanks for listening.